In this example, we have a binomial distribution with a number of trials equal to 10 and the probability of a success of 0.42. And we are to find the following probabilities. We are to find the probability that x is exactly 3. We'll do that by pushing second, variables distributions, and then going to Binomial Cdf. And then going to Binomial Pdf. The Binomial Pdf function gives us a probability associated with a single value of the probability distribution. So the number of trials then will be 10. The probability of a success was 0.42. And we were to find the probability that x was exactly 3. And if we are going to type this into a calculator that does not prompt for those values, then the order would be n, p, and then x. So n, the number of trials, this time it was 10. P, the probability of a success, was 0.42, and the number of successes was 3. Hit enter, and we get 0.196 if we round to 3 decimal places. The next problem says the probability that x is no more than 4. Now, no more than 4 means from 0 to 4 and including 4. So the probability notation would look like this. The probability that x is less than or equal to 4. Now, there is a function on the TI 83 and 84 calculators called Binomial Cdf, Binomial Cdf. And what it does is find accumulated probabilities. And the way it works is it finds those probabilities from 0 up to a number such as 4. So in order to use that function, we would push second, variables distributions, and then we would go to Binomial Cdf. Again, we will type in the number of trials. That was 10. The probability of a success, 0.42. And then the number of successes. And remember, this is the Binomial Cdf function. So it's going to add up all of the probabilities associated from x equal to 0 up to whatever number I specify here. And this was going to be 4. And again, if we are using a TI 83 or 84 calculator that does not prompt for these values, you'll type in n, p, and then x. So n, the number of trials, this time it was 10. P, the probability of a success, 0.42. And then x, the number of successes. And here it was 4. And we find that probability to be 0.582 when we round to 3 decimal places. So the probability that x is less than or equal to 4 would be 0.582. The probability that x is at least 6. Now that means from 6 up to n. N is 10. So we need to find the probabilities that x is equal to 6, 7, 8, 9, and 10 and add those together. In other words, the probability that x is greater than or equal to 6. At least 6 means greater than or equal to 6. Well, remember that the Binomial Cdf function does not find accumulated values in that way. It finds accumulated values from 0 up to a number. So what we need to do is subtract the probability that x is less than or equal to 5 from 1, because total probability for any distribution is always equal to 1. So if I start with 1, that would be the sum of all probabilities, and subtract from that the probability that x is less than or equal to 5, then I would wind up with what would be left would be the probability that x is equal to 6 or more. So what we're going to do is use the Binomial Cdf function again. So we're going to go second, variables distributions, and then go to the Binomial Cdf function. Again, the number of trials is 10. The probability of success is 0.42. And this time, our value is going to be 5. So again, our order here is NPX. Now here we get 0.798, but that's not the value that we want. We want to subtract that number from 1. So we want 1 minus this value, and that's going to give us 0.202 when we round to 3 decimal places. So the probability that x is greater than or equal to 6 is going to be 0.202. The mean and standard deviation for this distribution, well, the mean and standard deviation for a binomial distribution is the mean is equal to the number of trials times the probability of a success. So in this case, that will be 10 times 0.42. And that makes sense. If there is a 0.42 probability that something is going to occur, and we perform that exercise 10 times, then 4.2 out of those 10 times we would expect that we would be successful. The standard deviation is the square root of the products of the number of trials, so n, the probability of a success, and the probability of a failure. So in other words, n is 10, p is 0.42, q would be 1 minus p, or 0.58. And then remember to take the square root of that value.